Welcome to Pomodoro Joe for Thursday, June 15th, 2023. Today we're doing LeetCode problem 1161, maximum level sum of a binary tree. This is a medium problem. Given the root of a binary tree, the level of the root is 1. The level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. What they mean by maximal here is that the sum of all the elements at this level is the maximum sum of any of the levels. All right, so our example here, we've got 1 at level 1, we've got 7 and 0 at level 2, and 7 and -8 at level 3. So it looks like our max will be a sum of 7 at level 2, and that is what we return, level 2. All right, I think this is pretty straightforward. We'll put 25 minutes on the Pomodoro timer, and we will get started. So for this one, we will be implementing a level order traversal of our tree. Now this is sort of a standard tool that you'll want in your toolbox. So if you know the level order traversal of a tree, this will be pretty straightforward. If you're not familiar with the level traversal of a tree, then pay attention to this one. Learn the generic formula for a level order traversal. Then anytime you come across a level order traversal type problem, you'll have that tool in your toolbox and you can just implement the solution very quickly. All right, so for this one, we'll have some result. We'll set it to 0. Actually, we'll set it to 1 to start with, because that could be level 1. That's our root level. Oh, and we better check to see if we definitely have a root. Number of nodes in the tree is at least 1. All right, so that's good to know. So we have our result. At the end, we will return our result. Now, here I will implement a generic level order traversal, and then we'll fill in all the missing pieces for this particular problem. So in a generic level order traversal, we'll have our current level, then we'll have our next level, and then basically that's it, I guess. So we'll have our current level, we'll go through all the nodes in our current level, we'll add all their child nodes to our next level, and as long as we have some next level, then we'll keep going through this loop. So let's start with level. So we'll have our current level and we'll start with the root node. Then while we still have some nodes in our current level, we'll go through all those nodes, put their children in the next level, and then we'll swap out the next level for this level at the end of our loop. So we'll have some next level here. And that will be just an empty array to start with. Now I like to put it out here just to keep track of it. This also means that hopefully we only have to declare it once out here. Well, I shouldn't say that. We declare it once out here, we allocate that memory, and then we can just keep referring to that same variable each time. All right, so we create our next level. We're starting this next level. Now for every element in our current level, for node in our level, so for every node in our level, we'll usually do some type of processing with that node's value. For now, I'm just going to skip that, and we'll just go through the level order traversal. So if this node has a left branch, then we'll put that left branch into our next level. And the same thing with the right branch. If this node has a right branch, we'll put that right branch into the next level. I don't know why I keep getting off by one space here. Let's try this. All right, if this node has a right branch, then we'll put that right branch into our next level as well. And at the very end of our loop, we've built up the next level, and we can swap out this level for the next level. So we say this level is equal to the next level. So we're going through this level, finding all the nodes, taking their children, putting them into the next level. Then when we get to the end, we'll just swap out our levels. Our next level becomes our current level. Then we go through that next level and repeat until we don't have any nodes left. Basically, we get to all the leaf nodes, then there will be nothing in our next level, and we break out of this while loop. Okay, so this is our basic format for a level order traversal. Now, for our specific problem, we have to do a little bit more than this. We have some processing to do. So what do we need to keep track of? Well, we'll need to keep track of, let's see, the maximal sum so far. So we'll have maximal. And we'll set it equal to, well, we can set it equal to 0, I guess. It's probably this root value, but that's all right. We'll set it to 0 to start with. We also need to keep track of our current level count because we need to know what level we'll end up returning when we have our result here. So we need to have our level count, and that again will start at 0. What else do we need? We'll need to keep track of our current level sum. Now that we'll probably want in here. So we'll have our level sum. So this will start at 0. So for every level we go through, we'll be summing the values of all the nodes in that level. So let's see, so for this guy, for every node in this level, our level sum will increment or will increase by that node's value. All right, then out here, we can check if this level sum is greater than our current maximal. If that's the case, then our new maximal becomes this level sum and our new result becomes this current level count. So let's see. All right, so that means we do need to increment our level count. So we're starting level count at 0. We'll have to increment it here. Let's see if that works. We have our root to start with. Our level count will be incremented to 1, and our root is level 1, so that's good. Then for every node in the levels, that'll be our root level. We'll get the sum of that node's value, which is just our root's value. We'll put the roots left and right into the next level. Then we'll check to see if that sum is greater than our maximal. Now, this might not be totally true because I'm setting this level count to 0. Sorry, I'm setting this maximal to 0. But it's certainly possible that all of our values in our nodes will be negative. So I actually want to do something a little bit smarter here. Since I know we have at least one node, I'm going to set this equal to the root dot val. All right. That way we don't end up in a weird case where all of the values are negative. Okay. So we'll go through, traverse our level, get the sum, do some checking to see if that sum is greater than our existing level sum or our existing maximal so far. All right. I think this is looking pretty good. All right, let's give this a shot and see how well we do. And we pass. Let's submit this and see if we pass all the tests. And we do. And we do quite well, actually. So we pass all the tests and we get an 88% for runtime, or an 89% for runtime, and a 67% for memory. So that is not bad at all. So this takes our generic level order traversal type algorithm, and we plug in the specifics for this specific problem, meaning the level sum and the level counts. So once you know how to do the level order traversal, this problem becomes pretty trivial. Okay, we could go back and try to get a little bit better. We could maybe, sure, why not? Let's jump back. So one thing we're doing here, let's see, what could we do here that's a little bit faster? We could inline some of these things. I didn't do so well when I did this earlier today, so this might not actually help us, but it's worth a shot. All right, so we're just inlining those. It's fewer lines of code to parse, so that might save us a little bit. Let's try this. Let's just see. I just want to get maybe a little bit more so that we can get over that 90% level. And it does. It gets us to a 91% for runtime and a 24% for memory. So that's, hey, not too bad. You could do other things in here, like you could stack up these assignments. So you could basically put next level, level sum, and level count all in one line with comma separated values. I don't know if it's really worth it. So yeah, at this point, I'm pretty happy with this, 91% for runtime. So I think that's it for me. Check this one out. Again, this is LeetCode problem. What is this one? 1161, maximum level sum of a binary tree. This one's pretty fun. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.